Alright guys, welcome to another video, and this time it's about the collision detection that we already have in our tiled map game. Let's actually have a look at what is happening right now, and I think we should first remove these blue map objects that we're drawing, and also this is only drawn because of some comment that I answered, so don't mind that, don't mind this first if here, it's just a little bit modified. Basically it's all still like we had it when the series kinda ended. Actually a while ago, so let's just comment out all of this because we only care about the collision detection, and this obviously looks way better to work with. Also, the player, you might think that he jumps a little bit differently or something. I don't know if I removed that or if that's in, but don't mind it. The code is basically all the same. So what's the problem? Why do we take care about the collision detection? We already did that. At first, let's try what happens if we make the player bigger, because right now you can see he's just as big as one tile. Here are the bushes, here's the player, they're basically of the same width and height, and trust me, they are. Yeah, I just know that they are. I mean, you know it as well. So let's just go ahead, and when we create the player, we want to set its scale, for example, to 3. So it will be 3 times as big, and we will get a little problem. Do you see that? He is still colliding with stuff, but it's like there's a little player in the middle that's colliding and a big player out of outside of him. So that what's drawn is bigger than that what's colliding. Also, if we set the size to get width times 3, for example, and get height, so if we just make him like 3 times bigger than he actually is, we'll get this, and yeah, he's still colliding. It's all fine, isn't it? Well, not really. I mean, he's colliding, that's true. But check out this. I'm just walking to... that's just some, you know, you should know this effect in games, but now, if you walk in here, he's just falling through that, and then if we're in the middle again, he's already colliding again, and then again, falling through, and then colliding again. But if we're on the sides like that, he's falling through, and that's because... we are checking 3 points, as you can see pretty easily right here. For example, if we move down, if velocity is smaller than 0, we move down and we check 3 points, and these 3 points are this one here, this one, and this one. Now, this works fine as long as the player is just as wide as a tile, because then between these 3 points, no tile fits through them. But now 1 point is here and 1 point is here, and this tile easily goes through between them. So we definitely have to check more points if the player is bigger. And that's actually what we're going to do today. So yeah, let's start. At first, another thing that I notice is that people often just copied this code right here. It is not perfect, okay? This is just telling you about the basics, but you should probably, I mean, look at this. This is a lot. Don't mind this animation stuff, it's from another requested tutorial. However, it doesn't affect anything that we are dealing with right now. So, anyway, this is-cell blocked method. I think I probably put it in later. However, this is-cell blocked method takes an int x and y, and it actually takes a cell, and to get that cell we have to type out all of this ugly stuff here, and in the tutorial it's even worse. So what you actually want to do, if you don't have it yet, you want to create such a is-cell blocked method, which is right down here, and we won't let it take a cell, we will let it take a float x and a float y, and then we'll just go ahead and get the cell ourselves, so we don't have to write it out every time. So let's just take one of these. The values don't matter right now because, yeah, and we're saying cell equals this stuff here. And then we have this x and y, so we are just going to replace these x and y values with what we have. And the tile width, we can get that from collision layer.get tile width and collision layer.get tile height. Okay. So this already looks way better, but now we also have to check if the cell is not null. So what this method is doing right now, it's taking a float x and a float y, so we don't have to cast it to an int or do anything. We're casting it to an int, we're getting it with a getCell method, dividing by the tile width and height. Everything we're doing inside this method, we just have to write it once. That's way better. I could probably have just done it in the first place when I was doing the tutorial, but I thought this was kind of obvious. However, well, the cell, if that cell is null, if the cell actually has a tile in it, and if the cell's properties contain the key that we defined, block key, which is defined like up here, then it's actually blocked, and then we will collide in that place. So this method, this really small method, allows us to scrap a lot of code from here, because we just want to say is cell blocked, and then we just give it get x, and we can remove the int case, we can remove the tile width, dividing by that, and here just get y plus get height, and that's it. So we can do that for all of those now, and that is certainly way faster, just like that and that. And yeah, I'm probably just going to cut that out, because yeah, I'm just removing some values right now, which is kind of boring. Alright, so I guess I'm done, and let's just try it out if it's still working the same way, which it actually should. And yep, it is still working. There's still this bucket, of course we didn't fix that yet, but it at least is just way less to write and to read and to maintain, and way easier to read in the first place. So that's what matters. Okay, so now that we have that taken care of, let's actually get to the real problem, that is this one here. So how do we want to fix this? Well, like I said, right now we're checking 3 points, 1, 2, 3, and here it is, 1, 2, and 3. And now we want to check here and here and here and here and here and here. And if the player was like this big, we didn't want to spread these 5 points all over the place here, because that would just get us the same problem again. We actually want to check here, 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 all the way up to the other side. So we have to do more or less checks depending on how wide the player is and how wide such a tile is, because we want to check for each tile. For example, for that one here, we would like to check 2 points, one in the corner and one in the middle. So, well, we just want to check 2 points on them, because actually where we check them doesn't really matter, because it's relative to the player. But anyway, we want to check 2 points for each tile, basically, or so that we can make sure that no tile is going to fit through 2 of those checkpoints. For that, we can actually get rid of even more code, and that's pretty nice, actually. All that we have to do is we have to go and create 4 new methods. Private, or let's just make it public or something. Boolean collides right, not taking any parameters. Then we have one collides left. Then we have one collides top and collides bottom. So these 4 methods are going to do all the checks for us that we need, and we can actually just quickly go ahead and add a return statement to all of those, so that this guy is happy. But we don't want to return can jump, just false for now, okay? So we can just don't get these compilation errors. That is kind of not so nice. Alright, so false. Okay. Now what are these going to do? Like I said, they're going to check multiple points depending on the player's width and the tile's width. We actually want to increase, we want to go in a for loop. We want to go, for example, for the check bottom method, we wanted to check the player's bottom, so that's this line down here, and we would go from using a for loop from here, plus half a tile width to there, 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 and plus another half tile width to the other side. So let's just go ahead and implement it. It's actually not this complicated. Here in collides bottom, at first what we need is a float step, and this is going to, well, basically equals 0. And nope, what am I doing? Okay, so alright, let me start over. We want to get a Boolean collides. That's pretty simple, and this is going to equal false. By default, we are just going to return it in the end, and then the for loop comes. So in the for loop, we want to have this float variable called step, set that to 0 in the beginning, because we are going to add this step to the position that we're checking all the time. So if we are checking from down here, we would like to add this step, which is going to be incremented by half a tile width all the time. So this step has to be smaller than the actual width of the player, because if this plus the step, which would be here, is bigger than the width, we are obviously checking out of range. So while step is smaller than get width. And now, like I said a bunch of times, step plus equals collision layer dot get tile width divided by 2. Okay. Now that we are in the for loop, we just want to check for each of these steps. So collides equals is cell blocked, and now it's handy that we are not passing in a whole cell again, and just passing an x and a y coordinate. And now we have to pass in the actual world coordinates of that. So we have to get the x, and like I said, we're going to add this to the x position down here, get x plus step, and it's always going to be get y, because get y is on the bottom, and if we're checking the bottom, we just want to stay on the bottom and don't add anything to the y-axis. So there we go, we have if the cell collides, and think about it this way, we are figuring this out for all these points, and now imagine, for example, exactly in this case here, we would check here, 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 and here. So here collides would be false, collides would be false, then collides would be true, probably true as well, and then false again, then false, and in the end we would return false. So as soon as we once collide with one of these tiles or cells or whatever you want to call it, we want to return immediately or just break out of the loops. So if collides, then break out of here. And then we could actually write this in a shorter way so it looks more confusing, because I like that. You can also just do it like that, and then you can remove these here, and you're done. So we are checking if the collides that we're setting is cell blocked, and if that's true, we break out of this for loop here, so collides is still true, and return it. So yes, we collide on the bottom in that case. Now we just have to implement that for all these collides right, left, and top. But it's basically the same. So let's go ahead and create a boolean collides again, equal to false, return collides, do a for loop, and now we're checking on the top, which is basically the same as collides bottom. So get width again and increment the step by collision layer dot get tile width divided by 2. And then if a step if collides is true, which equals is cell blocked, and now that's where the change is. It still get x plus step, but like I said previously, if we're on the bottom, we don't want to add anything to the y all the time, which is why I just say get y here. But if we're on the top, we always want to add the whole height to the player, so we are doing the same just up here. So step and get y plus get height. And if that is, break out of the for loop and return the collides. Alright, now the same thing for collides left. Boolean collides equals false, return collides, for loop float step equals 0. But now have a look, we are colliding on the left side. So the left side is what? This here. What's different from this to this? Right, the axis, the direction in which we're going. Here we are incrementing the x value and having the same y value all the time, but here we are incrementing the y value and staying on the same x value on the time. So we have to actually check if step is still smaller than get height to be able to tell if we still want to check these points there. Then increment step by collision layer dot get tile height. Oh, come on. collision layer dot get tile height divide by 2, not width obviously, and if collides equals is cell blocked, then break, and in is cell blocked. Now we want to put, like I said, we want to increment the y value now, so we can stay on the same x, but we have to say get y plus step. And yeah, so get y plus step, step is 0, step is something, step is something, step is something. Get y step is bigger than height, so we don't want to check up here. Alright, just for the right one, and this time I'm actually going to copy it from the left one and just paste it in there. You should basically never do that because this is a bug source like hell, but I know what I'm doing, I hope. So right now we have to have a look at the coordinates again, because like on the left side we are incrementing the y value on the right side, but get x is the left side of the sprite, so we always have to add the width of the sprite, so we're always checking on the right side. Now that's all fine, but we are still not using these methods, so they're pretty much useless at the moment. Let's go ahead and reduce down a little bit more of code. So what do we have here? We have an if that says if velocity.x is smaller than 0, and this comment already says here if we are going left. Well, if we are going left, we would probably like to check if we are colliding on the left side, which we have previously done with these 3 checks here, but now are doing with varying number of checks depending on the tile height and sprite height. So we just want to immediately go ahead, we don't even need these brackets anymore because there's just one statement in, and we want to say collision x equals yeah, collides left, and this does the job for us. Same for this one here, collision yeah, x still collides right. Then we are reacting to the x collision in the same way, and move on y. In this case here we have collision y equals some crap, and then can jump equals collision y, so we can make this even shorter. We can just say can jump equals collision y, and that equals collides bottom, because we are going down, because velocity dot y is smaller than 0. And this comment is inappropriate there. Let's move this there, remove this there, and simply say collision y here equals stuff. Guess what? Top. That's right. Okay, so this should basically solve a problem if I didn't mess up anything. Let's try it out. We still have the fatty player here, and yep, we are totally not falling through this thing anymore. This is because we are now checking there, 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 and there. So I could even go ahead and make the player like, I don't know, Megalodon size. Get height times 20, 30. Oh my god, this is going to look crazy. Okay, it's actually so crazy that, well, yeah, it's still working. Oh, I don't know if this is actually, yeah, it's working. It's crap. This is just too big to see anything. Times 10 is probably already enough, so let's check this out. Yeah, this is already pretty high dude here. Pretty wide dude as well. And I'm not so sure. Yeah. Now, why is he colliding with this thing there, even though there's so much space between these? Well, that's pretty simple, because simply we were checking on the sprite, and the sprite is rectangular, and it actually goes from here like this to here and then up there. So that's just some transparent space there. That's because we are using a bounding box that's exactly the size of the sprite, and that yeah, just leads to those kinds of results here. So that's not really our fault. But right now he's so big that the transparent part goes from there to there. But yeah, we are not falling through it. We should definitely fall through it with such a small tile and just 3 checking points. But now we have all of those. There is actually plenty of checking points right here right now. So I think we're safe to say we now have a better collision detection, which allows us to... What actually happens if we set the scale? I think this works as well. No, because in set scale we are having actually still the same size, but not the scale. We could, if we wanted to, say we want to support this the scale as well. I think we could actually do that by going ahead and say we would have to, yeah, we would have to just increment all these values or decrement whatever, modify them by the current scale on X and scale on Y. But I don't want to do that now and figure out and mess up this video. So just don't use set scale, that's crap anyway. Just set the size. It's going to give you problems in your other calculations as well, because it's just the scale and not the actual size. So let's say the size is get width times 2 and get height times 3. So this would probably look a little bit realistic if this... He's pretty slim, okay? But it's working. Alright, so thanks for watching, and I hope this cleared up some stuff about the collision detection that has been done from the concept the last time, but not, yeah, perfectly. This may still not be perfectly. For example, we can't collide over slopes. But seriously, colliding over slopes with all this rectangular tiled map stuff is another complicated topic. And yeah, I'm not doing that right now. So yeah, I'm repeating myself like as usual in the end of my videos. So thank you guys for watching. I hope you actually learned something from this. I'm just going to let the set size on get width and get height times 1.5f or some, just to prove it's working. And yeah, you can as usual get the code in the repository that I'm going to put in the description. And if you haven't seen the other collision detection video, you should have checked that out first. I should probably have said that in the beginning. Alright, anyway, thanks for watching, see you next time, and yep, I'm out.